Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 21, Solids. Exercise 21A. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information. First, let's study the formulae of surface area and volume. Let's start with cuboid. Cuboid is a three-dimensional rectangle which has a length, breadth and a height. So the volume is L into B into H. The total surface area, that is the area of the six surfaces, six faces, is 2 multiplied by LB plus BH plus HL. That is the formula of TSA. The formula of LSA, that is a lateral surface area, or you can say the area of the four walls, 1, 2, 3 and 4. Not the top area or the bottom area, just the four walls is called lateral surface area, and the formula for that is 2 into L plus B into the height. Length of a diagonal. Now here diagonal will be from this corner to the farthest corner, this one. Think of it in a three-dimensional manner. So if this is a rectangle, we simply join the vertices to draw the diagonal. But here, diagonal means the longest stick which can be fit in this cuboid, which will be from this corner to this one, or it could be from this corner to this one, and so on. So the formula for that is square root of L square plus B square plus H square. And yes, this has been derived with the help of Pythagoras theorem twice. Similarly, we have some formulae for cube. Cube is a three-dimensional square. So all the sides, the length, the breadth and the height are same. We can call it A or we can call it S, the side. So the volume is length into breadth into height, which in this case would become A cube or S cube. The total surface area, that is the area of the six sides, for example the six sides of a dice, the total surface area is 6 into A square, which makes sense because each area is A square. That's the area of a square, and there are six faces. Lateral surface area, that means the area of the four walls, that will be 4A square. And length of diagonal again is from one corner to the farthest corner from there. So that will be square root of A square plus A square plus A square, which becomes A into root 3. Now remember, cost of anything is always the rate multiplied by the quantity, which could be rate into volume or rate into area. It all depends on the unit of the rate. That is a big hint. If they've given the rate as say rupees 10 per meter square, that means we have to multiply with area. If they've given the rate as rupees 10 per meter cube, that means we have to multiply it with the volume. Now let's start with exercise 21A. We'll do sum number 2, 4, 6, 8, 9, 11, mark the 11th one as IMP, 14th and the 15th one, mark 15th one as also as IMP. Note that you need to write the formula in each sum, write proper statements, do all the calculations on your own rather than just copying the final answer, and the units matter. Sometimes we may have to convert the units as well. Second sum, the volume of a cube is given as 729 and the total surface area has been asked. So from the volume, first of all, we can find the side, each side of the cube, which will be the cube root, which is 9 centimeters. And then the total surface area formula is 6 into side squared, which comes up to 486 centimeters squared. Next, the fourth sum. 75 persons can sleep in a room, and the length and the breadth of the room is given. Each person requires 16 meter cube of air. So that's the volume of air. Find the height of the room. Now we'll use a unitary method first. you could solve it in the tabular form as well. One person requires 16 meter cube of air. So 75 persons would require how much air totally? 1200 meter cube, which would be the volume of the room, because volume of the room is equal to the volume of the air it contains. But volume is always L into B into H, out of which L and B are given, so only height is asked. So we can solve further and get the value of height as 5 meters. Next, the sixth sum. There are 3 cubes whose edges are x, 8 and 10 centimeters respectively. They are all melted and recast into a single large cube whose edge is obviously greater than all 3 individually. 12 centimeters is the new edge. Find the value of x. Now we know that the total volume of the new cube will be equal to the sum of the 3 smaller cubes. So that's the starting point for the sum. The total volume of the large cube is equal to the 3 volumes. And they are cubes, so volume is always side cube. So we substitute the values of the sides. X is the only unknown variable. Solve it further, take the cube root, and we get the value of x as 6. No need to write x is equal to 6 centimeters because it's understood. It's mentioned here x centimeters, so x value is only 6. Next, the 8th sum. Now the cost of papering the 4 walls of a room. 4 walls means the lateral surface area. Do you remember the formula? Try to recall. Yeah, it's 2 into length plus breadth into height. So the cost is 75 paise per square meter. So that's the rate. And the total cost is given as rupees 240. So when the rate and the total cost is given, we can find the area. So let's first find the lateral surface area using this information. Note 75 paise will become 0.75 rupees. The height of the room is given and the length and the breadth ratio is given. So we can assume the length to be 5x and the breadth to be 3x. By using these values, we can find the value of x and hence we can find the values of length and breadth. So again, unitary method if you wish, or you can use the formula which is area is equal cost is equal to rate into area. So area will be equal to total cost upon rate. I've used unitary method, that is for rupees 0.75 we can paper area of 1 meter square. So for rupees 240, how much area can we paper? 320 meter squared. So that's the area of the 4 walls. But the formula is 2HL plus B, and since the ratio of L and B is 5:3, we can substitute them as 5x and 3x respectively. Height's value is given. Solve, get the value of x, and once you get the value of x, substitute again and get the values of length and breadth. Next, the 8th sum. Oh, the 8th sum is done. Now let's go for the 9th sum. The area of a playground is 3650 meter squared. Find the cost of covering it with gravel 1.2 centimeters deep. If the gravel costs rupees 6.40, yeah, we could have written as 6.4 as well, but for currency like rupees, we always write up to 2 decimal places, so we can even call it 6 rupees and 40 paise. 6.40 per cubic meter. Now, the fact that the rate is given in terms of per cubic meter means that we will have to multiply it with the volume. So that's a hint that we have to remove the volume here. So volume of a cuboid is LBH, but L and B are not given. That's okay. The area is given. An area of a rectangle is definitely length into breadth. And when they say 1.2 centimeters deep, it means the height. So this playground looks somewhat like this. It has a length and a breadth, and it has some thickness. So volume is equal to LBH, area is given, height is given. We have to convert the height because the area was in terms of meter square and the height is in terms of centimeter. So we should convert the centimeter into meter because even the rate is in terms of meter cube. So we got the volume do the calculations yourself. You need practice of calculations. And then once you get the volume, the cost is simply volume into rate, which comes up to rupees 280.32. Don't just copy this, do it. Next, the 11th sum is IMP. The external dimensions of a closed wooden box. There are two keywords here, external and closed. So in a wooden box, closed, the length, breadth and height are given, 27, 19 and 11. And the thickness of the wood is also given. We have to find the volume of the wood. So we'll have to draw a diagram to understand this better. This is a closed wooden box. Length is given, breadth is given and height is given. And the thickness is given. They want the volume of the wood part. Now, in the central volume, that's air or any content we may put inside this box. How will you find the volume of the wood? Clearly, it's total external volume minus the total internal volume. So, first let's find the external volume. The dimensions of the external volume are given, LBH. So we get the answer is 5,643 centimeter cube. But the internal volume, the length is definitely smaller than 27. In fact, it's going to be 27 minus 1.5 minus 1.5. So that's 24 centimeters. The internal height is again 11 minus 1.5 minus 1.5. And the internal breadth is again 19 minus 1.5 minus 1.5. I couldn't show that because it's a three-dimensional wooden box. So we get the internal dimensions and then find the internal volume as well. So the volume of wood is the total external volume minus total internal volume, which is this much. Second, what is the cost of the box if the wood costs rupees 1 rupee 20 paise per centimeter cube? So the rate is given, the volume we have found out, units are same, centimeter cube, so no worries there. We can simply find the cost by multiplying. And third one, if you want to fit it with small cubes, each with edge of 4 centimeters, how many such cubes would fit inside it? So number of cubes would be the internal volume of the box upon volume of each cube, because the cubes will be fit only in the internal volume. Internal volume we have already found. Volume of each cube is 64 and we get the answer as 48 cubes. Next, let's study the 14th sum. Now the square on the diagonal of a cube has an area of this much. In simple language, this simply means that the square of the diagonal is 1875. So we start with that. The square of the diagonal or diagonal square is 1875. Now, if you try to take the square root, we realize it's not a perfect square, so don't do that. Let's use a formula of a diagonal. For a cube, the diagonal formula is side into root 3. Squaring both the sides, it becomes d square is equal to 3 into side squared. But d square value we already know. That means from 1 and 2, 3s square is equal to 1875. Now solve it further and we get the value of the side of the cube, 25 centimeters. Second, they want the total surface area of the cube, all 6 sides. So that will be 6 into side squared, which comes up to 3750 centimeter squared. Next, the 15th sum, mark it as IMP. A hollow square-shaped tube. So this cross section is a square, but it's a tube, so it has a great height, if I can call it a height. So it's overall it's a cuboid. It's not a cube. Although the length, the length and the breadth are same here, but the height is different. The length and the breadth of the external dimensions are unknown, but internally we know it is 5 centimeters. And the height is 8 centimeters. For internal as well as external dimensions, the height will be 8 centimeters. Thickness is unknown, but the total volume of the iron is 192 centimeter cube. Now we know that the total volume of the iron will be the external volume minus the internal volume. So that's the logic we'll use for this sum. This is the diagram. The internal dimensions are 5 by 5. So can you tell me what will be the external dimensions here? 5 plus x, that is 5 plus 2x. And even the breadth will be 5 plus 2x. The height will be 8 for both internal and external volume. So first find the internal volume, then find the external volume, and we know that volume of the iron is external volume minus internal volume. And volume of iron is given. So now this is an algebraic sum. We use the square formula. A plus b the whole square is a square plus b square plus 2ab. Open the brackets. So 200 and 200 get cancelled. Shift 192 to the RHS, it becomes minus 192 is equal to 0. So that's a quadratic equation. Let's simplify it further by dividing by 32. So now splitting the middle term would become easy. 5x can be split as 6x minus 1x because that will give you 5x back again. And 6 into minus 1 is minus 6 indeed. Now take the first two terms together and the last two terms together. Take out common. When nothing is common, take out 1 common. And if I write minus 1 out, the sign inside will change. Don't forget that. And of course, the two brackets have to be exactly same. That's the whole point of this process. Take the common bracket out and we get two brackets. So we get two values of x. Reject the negative value. So the positive value is the final answer. And write the final statement.